Um, Hi guys, Mr. Omix here once again, and today I'll be trying to explain to you to teach you how to find the end stem of an exponential sequence. Okay, there are different type of sequence. You have the linear sequence, you have the quadratic sequence, we have the cubic sequence, we have the exponential sequence, and then we have the Fibonacci sequence. Okay, and then all of them have their ways of getting the nth term apart from the Fibonacci, okay? So what I want to do in today's class is just to explain to you how to find the nth term of an exponential sequence. Okay, so just permit me to share my screen quickly, and then we get into it. Okay, so now first, what is an exponential sequence? How do you represent or how do you identify an exponential sequence? Every sequence you have has a unique way in which you identify it's a sequence. For an exponential sequence, you'll notice that it is being multiplied by the same number. Take, for instance, if I have 1, 3, 9, 27, 81, 243, and so on. If I have 2, 4, 2, 4, 8, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, and so on and so forth. So you notice that each term is being multiplied by the same number. The moment this happens, it's automatically an exponential sequence. So getting the nth term for an exponential sequence is actually very, very easy. Very, very easy and very, very straightforward. So let me start with the two examples I wrote just now. Let me start with 3. Find the nth term of, okay, let me just write the question in full. Please don't forget, with all our videos, you can always pause, understand the concept before you hit the play button again. So consider this exponential sequence. Find the nth term of 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. And we can just have 3 dots saying that the sequence continues. Okay, so the first thing you have to do is you have to write all these numbers as a number or as a common base with different powers. Take, for instance, my 3 is 3 raised to the power of 0. Sorry, my 3 is 3 raised to the power of 1. 9 is 3 raised to the power of 2. 27 is 3 raised to the power of 3. 81 is 3 raised to the power of 4. 243 is 3 raised to the power of 5, and so on and so forth. Okay, so what do you notice? So what you would notice is 3 is common to all of them. So how do you find the nth term? So the first thing you do, the nth term, the first thing you do is you write the common number to them, which is 3. Then you go ahead and get the nth term of the powers. The powers are 1, 2, 3, 4, 5. Okay, and then just so you know, every single power, the powers in in an exponential sequence will always form a linear sequence. I'll say that again. The powers in an exponential sequence will always form a linear sequence, and I'm sure you remember how to get the nth term of a linear sequence. Not to worry if you don't understand. I'll re-explain quickly. So what we first do is we get the number that is added to each of them. Okay, so that's 1. Okay, so you just write your 1, and then you put n in front of it. And then you ask if there's going to be a number before this 1, what number would that be? Well, the number is 0. Okay, and then you just say 1n plus 0, which is basically the same thing as n, because when you write our letters, you don't have to put 1 in front of it. And obviously, if you add 0 to anything, it gives you the same thing. Okay, so you put the n as the power to 3. So the nth term for 3, 9, 27, 81, 243 is 3 raised to the power of n. Okay, so let me give you another example before we look at the exam style question. Let me just come up with another one that'll make it a bit more interesting. With this same ones, what if you have 1 over 3? You have 1 over 3 times 3, that's 1. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Let's just stop at this. Okay, once again, the numbers multiplied, all of them is 3, right? So if you write all of them in powers of 3, this is 3 to the power of negative 1. This is 3 to the power of 0. This is 3 to the power of 1. This is 3 to the power of 2. This is 3 to the power of 3. And this is 3 to the power of 4. Again, how the 1 over 3 become 3 to the power minus 1? It goes back to your indices. to remove the fraction, you can just put a negative power. Okay, that is indices. So what do you do for this? Again, the first thing we did was that the common base to them is 3. So bring out the 3. And then we write out the powers. The powers are -1, 0, 1, 2, 3, 4. Okay, so we use our knowledge of linear sequence to get the nth term of this. Okay, so again, what's the common number? The common number, you're adding 1. So write your 1, put n in front of the 1, and then you ask if there is a number before -1, what will that number be? Well, that number would have been -2. So the nth term for the linear sequence is n minus 2. Okay, and then you can remove the 1, obviously, and then that gives you n minus 2. Okay, so we now go ahead and get. So you go ahead and get the nth term of this, and that's n minus 1 n minus 1. We know we don't need to say 1 n minus 2. You can just basically say n minus 2. Okay, so let's go to some exam style questions that will teach us or how to do what we are doing. So let's look at some exam style questions quickly. Okay. So let's start with this. You have 3, 9, 27, 81. Okay, this is very so we are asked to find the next term. Okay, please hit the pause button, try it out, and then hit the play button later. Okay, so this is 243 since you're multiplying by 3. Okay, but I'm interested in the nth term. Okay, so let's assume the question asked us to get the nth term. So what do we do? I think we've done this already. Yeah, we've done this. So let's just go to the next one. Let's just go to the next question. Yeah, okay, so you have 1, 5, 25, 125, 525, 625, excuse me. So you can see that all of them is 5. They're multiplied by 5, okay? So this is just 5 raised to the power 0. This is 5 raised to the power of 1. This is 5 raised to the power 2. This is 5 raised to the power of 3. And this is 5 raised to the power 4. Please don't forget anything raised to the power 0 is 1. That's why 1 can be written as 5 raised to the power of 0, okay? So what do we do? The common base is 5. Write the common base down. And then you find the nth term of the numbers. So you have 0, 1, 2, 3, 4. Again, don't forget, this is always a linear sequence. 1 is the number being added. So write your 1, put n in front of it, and then you ask, if there is a number supposed to be behind 0, what will that number be? Well, that number is -1. You put -1, and then that's n minus 1, because again, the 1 in front of the n is totally not necessary. Okay, so moving on to another one. Okay, quickly try this out. We are looking at sequence C. In other videos, we'll be addressing all the other sequences, but for this video, we are looking at the exponential sequence, and this sequence C is obviously obviously an exponential sequence. So you have 1 over 2, you have 1, you have 2, you have 4, and you have 8. Okay, so this is 2 to the power of -1. This is 2 to the power of 0. This is 2 to the power of 1. This is 2 to the power of 2. And this is 2 to the power of 3. Okay? So again, the common number to them, the common base is 2. And then we can now take the powers. The powers are -1, 0, 1, 2, 3. Okay? Again, this is a linear sequence and 1 is being added. So if 1 is being added, right? If 1 is being added, you have your 1, you put n in front of it. And again, if there was a number before -1, what would that number be? Well, that number is -2, okay? And then the nth term is 2 raised to the power of n minus 2, okay? Let's try the next one again. Let's try the next one, okay? I'm particularly interested in this. This is the one that is an exponential sequence. So we have 1, 4, 60, and 64. Okay, again, please press the pause button, and then you can always hit the play button after you attempt it. Okay, so this is 4 raised to the power 0. This is 4 raised to the power of 1. This is 4 raised to the power of 2. And this is 4 raised to the power of 3. Okay, so obviously 4 is the common number. Again, find the nth term of the powers. They are always linear sequences. The common number you're adding is 1. So write your 1, put n in front of the 1, And then if there's a number before 0, the number would have been -1. So put your -1. So the n term is 4 raised to the power of n minus 1, because this one is obviously not needed. Okay, the last one we're going to try, or maybe we can take 2 more if we have time. Okay, so let's look at this one. I'm particularly interested in the 27, the 81, the 243, and the 729. Okay, we can do them together. Okay, so look at the 27. Again, this is 3 to the power of 3. This is 3 to the power of 4. This is 3 to the power of 5. And this is 3 to the power of 6. Again, 3 is the common number, right? And then you take the powers, you find the n term of the powers. If you find the n term of the powers, 1n plus 2, because if you have a number before 3, that number is 2, okay? And then you put that as a power, that's n plus 2. So it is 3 to the power of n plus. Okay, so if you want to combine it with what we have in the numerator there, so we'll go ahead and get the nth term of the numerator again, the 2, 3, 4, 5, these numbers here, the 2, 3, 4, 5 here. Let's get the nth term of this numerator. It's a linear sequence, so that's n plus 1, because the number before this is 1. Okay, so that means the n term of the fraction in general is just n plus 1 over 3 to the power of n plus 2, and that will be it. Okay. The final question we'll be looking at question C. This one has a decimal, right? We have 0.25, we have 0.5, we have 1, we have 2, and we have 4. Again, hit the pause button, and after you try it, you can now hit the play button. Okay, so the first thing to do is to write, again, how do I know it's exponential? I know it's exponential because when I'm multiplying by 2, I'm getting the next number. 2 is the common number, okay? So let's write this as fractions. This is 1 over 4. This is 1 over 2. This is 1. This is 2. And this is 4. Okay. So this one is 2 raised to the power of -2. This is 2 raised to the power of -1. This is 2 raised to the power of 0. This is 2 raised to the power of 1. And this is 2 raised to the power of 2. Again, what do? The 2 is common, write the 2 out. And then find the nth term of the powers. Find the nth term of the powers. Okay. So if you find the nth term of the powers, that gives you, if we find the nth term of the powers, I think I just closed that by accident. I think it's here. Okay, sorry, it's here. Okay, so we will now find the nth term of the powers. That gives us 1n, and then the number before -2 will be -3. Okay, so that's just 2 raised to the power of n minus 3, and that is the nth term for the sequence. Okay, so I hope you've learned how to find the nth term of an exponential sequence. Please stay tuned for more videos with respect to different topics in IGCSE. Thank you so much. See you next time. Bye-bye.